Hello, everybody. My name is Jack Mino-Altherr, and today we'll be going over merge sort, which is a type of sorting algorithm. So what is merge sort? It was created by John van Neumann in 1945. It is a divide and conquer algorithm, and it's often compared with quicksort as they're both divide and conquer algorithms. Merge sort is stable, meaning equivalent elements will retain their relative position, which is very helpful if that's something that you're looking for in a sorting algorithm. It works best in average runtimes, or O(n) times log 2 of n, which is with a space complexity of n. And typically, it's not in place. And it's considered a very difficult algorithm to implement in more complicated linked lists and arrays. And there are many different variants of merge sort. So who was John van Neumann? John van Neumann was a Hungarian-American mathematician and computer scientist. He was often considered the last of the great mathematicians. He worked on many different projects, including the Manhattan Project, which is a little bit more infamous of a project. He helped build the atomic bombs with many of the other great scientists in America during World War II. He helped discover the structure of DNA, helped develop game theory, which has applications in all social sciences and ways the participants gain and losses in different scenarios. It's often used as a type of philosophy and as many different, it's very important in social sciences. And cellular automaton, which is basically the structure of cells and visualizing small things that we can't see, like DNA, like something else I just mentioned. He was considered a child prodigy. At the age of 6, he could speak Greek, English, French, German, and Italian, all at the age of 6. And at age 8, he could do basic calculus like integrals and differentials. He was considered a very chaotic person. He loved chaotic environments, and he often drew complaints from Albert Einstein as they worked together because he would play loud German music all the time. He loved to go into cities and work on his math and just loved the sound, the chaos of the environment around him. He would often gossip with friends and joke around, and he was a very personable person. Eventually, he died at the age of 53 from prostate cancer. So what is a divide and conquer algorithm? A divide and conquer algorithm breaks down a problem down into 2 or more subproblems. And it's used in sorting as well as synthetic analysis, which is parsing, such that like computer science, like parsing through errors, or just grammatical errors in English. It's also used in discrete Fourier transforms. I'm currently taking ELEG 305, which is signals and systems, so that it relates to that if anybody else takes that class. And it's good for multiplying large numbers, such as Karatsev's algorithm, which is a different type of divide and conquer algorithm. And it's very useful in solving complex problems. It's a very efficient algorithm and can yield more accurate results to a problem than most other methods. So how does merge sort work? Merge sort divides an unsorted list into n sublists, each containing 1 element. So you'll see in the picture that it'll divide it divided by 2 each time up until it gets a single element in each of that's just a single element. And then the merge part comes in, and you'll merge each of these and at the same time sort them based on their number. So you'll see 27 goes to the left and 38 goes to the right for that specific example on the far left. And then it'll keep doing this and compare them and combine them together up until you get a fully sorted, completely merged array. There's also an interesting video I'd like to show that shows how it works. So let me make this go a little bit faster. But as you can see, it's going to combine, it's going to split them up into little sublists, and once they reach equal size, they'll combine them together. This is a little bit different kind of merge sort. There's many different types, but this is basically a fun way to visualize it. It's a very interesting video to see. And you'll see how eventually they'll combine these two sublists into this fully merged list. So variants of merge sort. Top down is one of the more common types of merge sort, and it uses recursion, and it'll constantly call upon the first part. It'll split them all up, so it'll constantly call and use recursion to split it up into all those separate elements, as I talked about before, and then I'll recall merge, and I'll just merge all the different things together and sort them. And then bottom up does not use recursion. Instead, it loops around the array and doesn't break the array apart. And it uses intervals of array sizes. And then three-way merge sort, the complexity actually decreases. It turns into log 3 of n. However, it's not the most effective way to use merge sort, as it has more comparisons to go through. So a three-way merge sort splits it up into 3 groups rather than 2 groups, and constantly splits up in 3 groups and then merges them together in groups of 3. So that's a little bit different way of doing that. And then natural merge sort identifies pre-sorted areas, or runs as they're called, and it merges them together, skipping. So basically, if something's already in order, it'll just skip over that part. It's a little bit quicker of a way to use merge sort. And then in-place merge sort is not actually in place, and it's more of a practical kind of thing. But it's the idea of trying to limit the amount of space that's constantly used in merge sort, because the space complexity is always n. And many times they try to fix that and try to make it less than n, or a little bit less than n, but it's not fully perfected method. And then block merge sort is another type of implementation of in-place merge sort, and uses 2 merge operations and an insert method to combine the different sublists. And then polyphase is often used in tape and disk drives when it's too large to fit in memory. And it sorts the list using an initial uneven distribution of sublists. So this is the way to think about bottom up. It's a little bit, many of these are much more harder to visualize than top down. But top down is the most usual occurrence of merge sort. So it'll just loop through, and it'll combine each one like this, and it'll just compare them into these little sets rather than constantly splitting them apart and using recursion, ultimately getting this alphabetically sized array. So when is it effective? Merge sort works very well for lists that can only be accessed sequentially and are very slow to access. This means programming languages like Lisp, where data is accessed sequentially almost always, is prioritized using merge to sort. It also works well for tape and disk drives, as mentioned before, with polyphase merge sort. And linked lists are also a major data type that almost always uses merge sort. Very effective for that. So when is it not so effective? When is it not so effective? So sadly, it always has O of n working memory requirement, but obviously there are ways people try to work around it, but usually it's O of n working memory requirement. And yeah, variants of merge sort attempt to fix this problem by reducing space complexity and the cost of copying, but there's no perfect solution to this problem. And merge sort is not very effective for data that's non-sequential, and overall, it's not very useful for any smaller kind of tasks, smaller type of arrays, lists. So it's not something you would use on the average array. So in summary, merge sort is very useful for sequential data types like linked lists. It's not so great for anything else. And it's a divide and conquer algorithm. as you can see, it divides and conquers. It divides it and then it merges it together. And there's plenty of different variants of merge sort. This is the final picture. This is a very helpful picture to see merge sort. And yeah, that's merge sort.